Hello. We've learned how to use uh, breaking a problem down into methods such as turn right would turn left 3 times, or back up, turns around and then moves and then turns around. We've learned how to use this idea of defining methods to make it easier to solve complicated problems. And what I want to look at right now is how to use top-down design. Start with a big problem that we want to solve, a complex problem, and look at how can we break it apart into small pieces. And the thing we're going to make sure that we do as we do this is we're going to make sure we don't think in Java. In other words, we don't want to think in terms of what Java can and can't do, moves and turn lefts. We don't want to think at the level of moves and turn lefts, because that's going to make it very difficult to solve this problem. Instead, we're going to think in English, or whatever your native language happens to be. We're going to think in English. In other words, we want to reason about the problem the way we would normally reason about that problem, as if we were trying to solve it, and not based on the limitations of the programming language. And we'll gradually introduce constructs. All right, let's see this in practice. So here's a problem. In this problem, I have a robot, as usual, and my robot is faced with this comb-shaped region, comb, C-O-M-B, and the task is to fill that comb, to darken every square in that comb. Why? Because this robot hates light squares, and he really wants to see this whole comb dark. It's very important, so we really need to enable our robot to solve that problem. So let's take a look at how to solve it. So I'm going to create a new file for this. I'll call it comb. Let's save that as comb. Sure, that sounds good. So it's been saved as comb.java, and I'm going to define a method. Remember, a file consists of a number of methods, and this is the incantation we write whenever we want to define a method, public static void, and the name of my method will be, let's say, darken comb. It's going to darken the entire comb. And to make life a little bit easier for me, I will load the comb world as the first step of darkening the comb, and then it will be my task to actually carry out the rest of the darkening of the comb. So how do we darken this comb? Well, based on the earlier videos, you might be tempted to say, well, I would turn left, turn left, turn left, make dark, move, make dark, move, make dark, and so on. We could do that, but that's actually that's thinking in Java. That's thinking in terms of the constructs we have. We want to try to think in English. We want to think in our native language. So, how can we darken this comb? How can we describe how to darken this comb? Well, that's pretty easy. We darken each spoke one at a time. So we would darken the spoke that's to the right, and then we'll move to the next spoke, move to next spoke. And what I'm doing here is I'm going to assume I have the perfect methods. So darken spoke, move to next spoke. Maybe these should have been called tooth. If it's a comb, I guess you call each one a tooth, so fine, we'll call it a tooth. Darken tooth, move to next tooth. And so I darken a tooth, I move to the next one, I darken that one. I have 5 teeth. So 2, 3, 4, 5. And when I've darkened the last tooth, I don't need to move to the next tooth. Let's make sure that's all on the screen here. Oh, I remember that whenever I call a method, I'm supposed to write the name of the file. These methods are going to be defined in the comb file just as soon as I implement those methods. So sure, we'll throw in the word comb there. It's going to turn out that word comb is optional, but I'm going to stick to this convention for now, where every time we call a method, we have the file that the method appears in, and then the name of the method. So darken the tooth, move to the next tooth. So this is top-down design, and it's kind of an optimistic way of programming, where I write this and I say, great, I'm done. I'm going to hit F5 to compile now, and then, my word, it turns out it doesn't compile because, let's take a look at that, Java has never heard of darken tooth. Okay, no problem. Now, I will go ahead and write darken tooth. So that's a new method, public static void darken tooth. Like so. And how do I darken a tooth? Well, how do I darken the tooth? I need to turn right to face the tooth. Turn right. I'll assume I'm defining turn right in this file. And then I'm going to sort of... Actually, this would be a good time to talk about before and after conditions. Before I darken the tooth, what assumption am I making? I'm assuming there is a tooth, and where's the tooth? It's to my right. So there's tooth is light colored, and it's to my right, or to the robot's right. And afterward, what should I assume? Well, I can assume anything I want, but I would like to assume that the robot's in its initial position. Robot hasn't in original position, no net change in position, and tooth is now dark. So I think that will be an easy set of pre and post conditions, or before and after conditions, to work with. But I think if you don't write out your before and after conditions before you write the method, at least you want to consider them before you write your method, or sort of update them as you write your method and you discover them. So let's see, we'll turn to the right, and then I could move, make dark, move. Actually, I guess I have to make dark first. Make dark, move, make dark, move, make dark, move, make dark. We could do that. But let's make life easier. Let's imagine the perfect method. Move and make dark. Actually, I'm going to go with move and make dark, which is, I think, contrary to what I just said. So move and make dark, which will move one step and then make dark. And then move one step, make dark. So how many times do we need to move and make dark? 1, 2, 3, 4, 5, 6. 6 times. 2, 3, 4, 5, 6 times we move and make dark. And at that point, we're sitting at the end, facing outward, east. So what do I need to do? I need to turn around. So we'll imagine that we can ask my robot to turn around. And then I need to walk all the way back. So that's 1, 2, 3, 4, 5, 6 times I need to move. Move is something I can directly ask the robot file to do. Move 3, 4, 5, 6 times. And when I get to the end, I'm facing west, so my post condition, my after condition said I'm supposed to be facing north again, so that there was no net change in the robot's position or direction, so I should turn right at the end, and turn right is not something a robot knows how to do, so I'll define that for myself. So see how I'm thinking at a higher level perhaps than just moving and turning, although there are some moves and turns that are starting to appear. Let's try compiling that. Now it's upset that I've never written, oh man, it's upset about a lot of things, but we're not going to let all those error messages bother us. That's just letting us know we have more work to do. Move to next tooth. We need to write move to next tooth. Okay, let's write that. Public void move to next tooth. I forgot the word static. Just going to let me call it on the file, but we'll learn that later. Move to next tooth. And move to next tooth, actually it should really be darken to next tooth, because we need to darken the region in the middle. So let's see, that would be, when I get to the end, I've actually darkened these 6 squares, but I haven't darkened the original square. So the first thing I guess I better do is make dark. And then I need to, you know, it would be an interesting precondition. We should talk about my before and after conditions. What if we assume that the square is already dark? Because that will let me jump in and use my move and make dark, which is going to be in my COM file. Move and make dark again is going to move and then make dark, and then move and then make dark if I call it a second time, which I will. So I'm going to assume that that first square is already dark. I think I'll go back and fix that later. But okay, let's assume it's already dark. So move to the next tooth really just means move and make dark twice, and now we're at the next tooth, and notice this square is now going to be dark. So therefore the next time when I use move to next tooth, I'll be pleased that this square is already dark, and I'll move and make dark for the next 2 squares. Okay, so far so good. I'm compiling. It tells me it's never heard of turn right. Well, that's no problem. I know how to write turn right. I've done that before. That just means I need to turn left 3 times. Compile again. Now it's upset because, oh, move and make dark. We have to write that. That's no problem. Public static void move and make dark. Let's make a note of my before and after conditions. I'm going to advance the robot. So the original cell is now dark, and robot has advanced to the next cell or square. So what must be true beforehand? Well, original cell is light, or robot on light, light colored cell, and the front must be clear if I'm going to be moving forward. So move and make dark, that's easy. Move and make dark. It's a well-named method. It's very clear what that method does. Move and then make dark. Let's go ahead and compile that, and now it says, oh, it's never heard of turn around. Well, that's no problem, because turn around is going to look an awful lot like the code for turn right. So maybe we'll even start with the turn right code. Turn around is simply going to tell the robot to face the other direction. That's two turn lefts. We've already written that method before too. Go ahead and compile. Oh, look at that, no more errors. I'm sure we nailed it then. Let's see, what was it called? Darken comb. So, and this is in a file called comb. Darken comb. Right, and I'm calling now my original method up here. And you can see there's my robot darkening the comb just like we wanted. I know, we skipped the first square. Why did we skip the first square? Well, because move to next darken tooth darkens to the right, move to next tooth darkens ahead, nothing darkens the original square. So we can solve that maybe by making the original square dark before we even start. Let's try compiling and running that. That's because we only want to do this once. So, alright, let's try again. And notice it's kind of slow. It's starting to annoy me how slow it is. So we can use a trick. I can ask, there's a magic method out there where I can change how long it will pause as the robot moves. And it's called set delay. So this means it will pause 100 milliseconds between moves and turns, and darkens and lightens and so on. So compile. I think it's happy. Let's try again. Uh-oh. What was it called? Comb, darken, comb. And there it is. Hey, look at that. Okay, it's coming around. It's going to the fourth tooth. Look at that. It's darkened the fourth tooth. It's going for the fifth. Is it going to finish? Is it going to finish? Huh. Why did it go back to the upper left? Well, because that's what our darken tooth method said to do. It said go all the way down, darken, go all the way back. So, yeah, by breaking it down into these beautiful methods, we've made the robot do more work. Right? We made it go all the way down and back an extra time. Do we care? Not particularly. We don't mind that the computer did more work because it made the problem easier to solve. So that's what we mean by top-down design. Start with the original method, be optimistic, assume you have the perfect methods, break it into high-level constructs like darkening a tooth, then break that down, darken tooth. We broke and move to next tooth. We broke those down into things like turn right, move and make dark, turn around, and we used all of those collectively to solve the problem. I'll see you in the next video.